If you think NVIDIA makes money selling graphics cards, you're analyzing the wrong business. The gaming GPUs inside PCs are the most visible part of the company, but visibility is not the same as leverage. Games made NVIDIA famous, but artificial intelligence made it indispensable. Today, many of the most powerful computers in the world depend on chips designed by a company that originally built its reputation rendering video game graphics. So the real question is not why NVIDIA builds powerful graphics processors. The real question is why those processors have become the computational foundation of the AI industry. To understand that shift, you have to go back to the company's origins in the early 1990s. NVIDIA was founded in 1993 by Jensen Huang, Chris Malachowski, and Curtis Preem with a simple belief about the future of computing. But the architecture they built for video games would eventually become the computational foundation of the artificial intelligence industry. In the early 1990s, the personal computer industry was expanding rapidly. Games and visual applications demanded increasingly complex graphics, but traditional processors were not designed to handle that workload efficiently. NVIDIA focused on designing specialized chips capable of rendering complex graphics much faster than standard CPUs. These chips became known as graphics processing units, or GPUs. For years, the company's success came from the gaming industry. Gamers wanted smoother frame rates, richer environments, and more immersive digital worlds. GPU performance quickly became one of the defining features of high-end gaming computers. But inside those graphics processors was a capability far more powerful than rendering digital scenes. Unlike traditional CPUs that handle tasks sequentially, GPUs are designed to perform thousands of calculations simultaneously. This architecture allows them to process enormous volumes of mathematical operations at the same time. So what happens when a chip built for video games becomes the most efficient processor for large-scale computation? Researchers began experimenting with GPUs for scientific simulations. Physics models, molecular research, and financial calculations suddenly ran dramatically faster using graphics processors. But the real transformation arrived when artificial intelligence began scaling rapidly. Training modern AI systems requires enormous computational power. Machine learning models process massive datasets while adjusting millions or even billions of parameters during training. Those calculations are highly parallel, and parallel computation is exactly what GPUs are designed to perform. This is the moment the business model begins to flip. Graphics cards power games, but GPU architecture powers artificial intelligence. Gamers made the product famous, but AI companies made the platform essential. The visible business is gaming hardware. The hidden advantage is the computational engine behind the AI revolution. Today, NVIDIA chips power a large portion of the world's AI training infrastructure. Major technology companies, research labs, and cloud providers rely on NVIDIA hardware to train advanced machine learning systems. So what happens when one company becomes the default platform for a rapidly expanding technological industry? The scale becomes enormous. NVIDIA now generates more than $60 billion in annual revenue, and its data center division has become the fastest-growing part of the business. Individual AI-focused GPUs can cost tens of thousands of dollars each. Some AI clusters contain thousands of GPUs working together, creating infrastructure investments worth hundreds of millions of dollars. At times, NVIDIA has controlled more than 80% of the global AI accelerator market. But hardware alone does not explain NVIDIA's position. Software plays a critical role. Over time, NVIDIA developed a programming platform called CUDA that allows developers to write software specifically optimized for NVIDIA GPUs. CUDA became the bridge between NVIDIA hardware and the applications built on top of it. Developers began building tools, libraries, and frameworks specifically around CUDA. Once machine learning researchers optimized their models for NVIDIA GPUs, entire research pipelines began depending on that architecture. Over time, CUDA became more than a programming tool. It became the standard language many AI systems use to communicate with hardware. Machine learning libraries, research frameworks, and AI development tools began integrating CUDA deeply into their systems. So what happens when thousands of developers build their tools around a single hardware platform? Switching becomes difficult. Applications written for CUDA run most efficiently on NVIDIA GPUs. Competing hardware platforms must convince developers to rewrite software that already works. That creates a powerful ecosystem advantage. But here is where the system becomes even more interesting. AI companies do not simply need faster chips. They need entire computing systems capable of training increasingly complex models. NVIDIA began expanding beyond individual GPUs and started building integrated computing platforms for artificial intelligence infrastructure. The company now provides high-performance GPUs, networking hardware, and software frameworks designed to work together inside massive data centers. Pause and consider that for a moment. Most people think NVIDIA sells graphics cards. In reality, the company increasingly provides the computational infrastructure powering artificial intelligence. And once a company becomes deeply embedded in an ecosystem like that, something important begins to happen. Demand compounds. If AI companies train models using NVIDIA GPUs, developers build software optimized for NVIDIA architecture. If developers optimize for NVIDIA, cloud providers install more NVIDIA hardware. If cloud providers install NVIDIA infrastructure, more companies build their systems on the same platform. But if competitors can design powerful chips too, what exactly prevents them from replacing NVIDIA's platform? The answer is the ecosystem surrounding the hardware. Years of software development, engineering expertise, and infrastructure integration reinforce NVIDIA's position. Replacing the hardware would often require redesigning entire software stacks and computing environments. That switching cost creates a powerful barrier. And once that barrier exists, the system begins to scale. If artificial intelligence adoption increases, demand for computational power grows. If demand for computation grows, companies build larger AI training clusters. If those clusters rely on NVIDIA architecture, the ecosystem becomes more entrenched. And if the ecosystem becomes entrenched, NVIDIA gains extraordinary influence over the infrastructure powering artificial intelligence. That escalation ladder explains how the system compounds. So the next time you hear about breakthroughs in artificial intelligence, remember that behind those systems sits a layer of specialized hardware performing trillions of calculations. Most people analyze the graphics card inside a gaming computer. Sophisticated observers analyze the infrastructure powering the AI economy. Because in technology industries, the companies with the most influence are rarely the ones building the applications. They are the ones building the platforms the applications depend on. And that is why NVIDIA's real business was never just graphics cards. It is the computational infrastructure behind artificial intelligence.